Basic exponent rules, the most basic ones there are. That's what we're going to go over right now. There's going to be a ton of new exponent rules and different things we're going to be learning in Algebra 1 this year. But before we can get to any of that, we need to make sure we know the basics. Let's take a look. The directions say simplify each expression using exponent rules. So the exponent rules are that when you multiply like bases, so x times x, like bases, you add the exponents. And when you don't see an exponent, there's really a 1 there. So x to the first times x to the first would then be x to the second. When you have like bases, you add your exponents. So then for the next one, if I have y times y times y times y to the first times y to the first times y to the first times y to the first, I add up all those exponents, I get y to the fourth. For the next couple, or the next few going forward, I'm going to see that I have x to the first times x to the first. But then I have a different base, y to the first, y to the first, y to the first. So x to the first times x to the first would give me x to the second. Y to the first times y to the first times y to the first would give me y to the third. And because it's all multiplying, notice my final answer is side by side, because remember, side by side means multiplying. Next one, y is by itself. So I don't have anything to multiply my y with. But now look, I have z times z times z times z times z. How many z's do we have there? We have 1, 2, 3, 4, 5. So that would mean my final answer is y times z to the fifth. Sometimes they're not expanded out. So these first few problems were all in expanded form, and now I don't have them in expanded form. Now it's just simply following the rules. X to the second times x to the third. We add the exponents of like bases. 2 plus 3 is 5. So my answer is x to the fifth. Same thing for the next one. X to the fifth times x to the fourth. When we have like bases, we add the exponents. 5 plus 4 is 9, and so my answer is x to the ninth. Y to the sixth times y. Remember, anytime you see a variable and you don't see an exponent, there's really always a 1 there. So y to the sixth times y to the first would give us y to the seventh. Awesome. Here's the next rule. Now, when you have one base and you have a power raised to a power, when I say power, I'm talking about the exponent. X to the fourth is now being raised to the third power. It's a power to a power. I don't have two bases anymore. I only see one base of x. The rule for power to a power is that we don't add these numbers together. Instead, we multiply them. X to the fourth to the third power would then become x to the 4 times 3, which is 12th power. Now, if you're like, well, how am I going to memorize that? I don't know what I'm doing. Think about it. We know the third power would mean to multiply something by itself 3 times. So this is really saying to do x to the fourth times x to the fourth times x to the fourth. And if I was to write that out, we know with like bases, what do we do with those exponents? We add them. What's 4 plus 4 plus 4? It's 12. Instead of rewriting all of this out every single time, if we remember this rule that a power to a power means we multiply it, it's going to save us some time. So now the same thing for the next one. Y to the third to the second, a power to a power we multiply. 3 times 2 is 6, and so my answer is y to the sixth power. So now I'm going to use these skills from the previous problems again here. So we have more variables. X to the second times x. Remember, power time, when we have two bases, that's when we add the exponents. So x to the second times x to the first would be x to the third. Y to the third times y to the fourth. Like bases, you add your exponents, would be y to the seventh. In the next one, I see I have an a to the fourth and then a to the fifth. They're not next to each other. I don't want you to think that now it's something different. It's not. They're just in a different order. A to the fourth times a to the fifth would give us a to the ninth. B to the eighth times b to the second. I add those exponents. That would give me b to the 10th. C to the third times c to the fourth would give me c to the seventh. Now I notice I have d and I have b. Those are not like bases, so b would hang out by itself. Then I would have c to the 7th, and then d. Notice I put my answer in alphabetical order. That's always a great way to put your final answer. Last two problems. The other rule that we did not talk about yet is when you are dividing, you don't add the exponents, you don't multiply them. Let me go back here. If I multiply the same bases, I add the exponents. If I multiply, I add the exponents. So if I divide, I do the opposite. Instead of adding, I subtract them. So 5 minus 2. And so that would give me x to the third. Here's the reason for that. X to the fifth looks like this. It's 5 x's multiplied together side by side, divided by x squared, which is 2 x's. If I think about what I can simplify in this fraction, I can cross out one pair of x's, a second pair of x's, and look what I'm left with. I'm left with x to the third. Same idea here. If I have y to the 8th divided by y to the third, when you divide with like bases, you simply subtract those exponents, and 8 minus 3 is 5. I hope this video was helpful. Thank you so much for watching.